Greetings, mathematicians of all ages. Today we're going to look at something called the distributive property. It's a property you'll see the next couple of years. Today is the goal is to give you an overview, kind of see where it comes from, and then we'll discuss a little bit about its uses in the future. So, and you notice I have some graph paper here. I won't need it for the whole assignment, but it is useful here in the beginning, so we'll see if I leave that on the whole time. Alright, to discuss the distributive property, one of the easiest places to start is actually with the area of a rectangle. Okay, so here is a rectangle. You can see that it's 1, 2, 3, 4 units wide. It's 1, 2, 3, 4, 5, 6, 7 units long. So 7 would be the length, 4 would be the width. Usually with rectangles, it doesn't matter which way it's turned, you pretty much always call the longer one the length. Okay, and if we wanted to find the area of this rectangle, if it's written on graph paper, I think it's not terribly difficult to see. You just can kind of count the rectangles, 1, 2, 3, 4, 5, 6, and so on, and you count them all. You get the idea. And there would be 28 squares here. Now, if we were talking, if these each represented an inch, then we would have 28 square inches. That's how we can write it. Now that you know exponents, you know that the 2 means squared, so we can write square inches. You can also write that as 28 square abbreviated and inches abbreviated. Okay, so it's pretty easy to see how you'd count all those 28 within the 4 by 7, and then maybe just one more. Let's do like a 2 by 5 here. So it's 2 wide, 5 long. Again, I could count them and I'd get 10 square inches. And if they were centimeters, I could call them that, whatever. Now you're probably also noticing that the relationship between this number, and this number. See if you can figure that out. And then also this number, and this number. You probably see that it's just simple multiplication, right? If I multiply the length and the width, I can get the area of a rectangle. Now, what on earth does this have to do with something called the distributive property? Here we go. Alright, the distributive property, in a geometric sense, has to deal with if I have, let's say this box. Did I draw it the same? Sure enough, 4 by 7. Alright, so if I have this 4 by 7 box, and I actually break it up into 2 separate chunks, we'll say this box and this box. It is the same. You could count all the squares and you'd see that it's 28 squares for each. Okay? But now my new dimensions are, it's still 4 on that side. The new length on that side is 3. And then this one's still 4. And the new length on this side is also actually 4. Okay? So what we can do is we can say, if I wanted to find the area of the 2 rectangles on the right side, there's 2 potential ways to do it. I can either have the area of this first rectangle and add it to the area of this second rectangle. So in the previous example, we just did like 2 times 5 to get the area. So I can do 4 times 3 to get the area of this rectangle, 4 times 4 to get the area of this rectangle, and that would be 12 plus 16, which would still give me 28, right? The other way to think about it is I have the 4 here, and that doesn't change from one to the other. So what I can do is I can do 4 times, and then I can add these 2 numbers up. 3 plus 4. Okay? And now what I'm going to do is take these 2 and just kind of write them together to show you how the distributive looks. So if I have 4 times 3 plus 4, that can equal 4 times 3 plus 4 times, not 2, let's try again, 4, right? And if you do the math, that works out. Order of operations, say you do this first, that'd be 7. This would be 4 times 7, and as we said before, this would be 12 and a 16. And it works out to 28 per side. Okay, Let's just look at one more quick geometric example here. Let's save myself a little writing here. Let's do a 2 by 5 again here. No, I take that back. Let's do a 2 by 9. 4, 5, 8, 9. Okay. And what I can do is I can break it up, and we're going to break it up into a 2 by 4 and a 2 by 5. Okay. So the original was a 2 by 9. Here we have a 2 by 4 and a 2 by 5, right? And now if we kind of ignore the first one, and we're again looking at these, the two ways to do it would be 2 times, and I add up the bottom, and this would look a lot like our original 2 times 9, but that can also look like 2 times 4, that gives me the area of the first box, plus 2 times 5. And I did that again. 2 times 5. And either way, I'm going to get 18. Okay? So, this, in essence, is the distributive property. If I'm reading out of my book here, it says, distributive, numbers added or subtracted within a set of parentheses can be multiplied by a number outside the parentheses. Okay? So the 4 and the 5 are added or subtracted inside parentheses, and each individual one is actually multiplied by the number outside the parentheses, which is 2 in this case. So let's just pick some more random numbers here out of the blue. If I do 3 times, and let's do a subtraction this time, 6 minus 2, remember it said any numbers added or subtracted within parentheses can be multiplied by the number outside the parentheses. I do them one at a time. So what I'll do is, you can see over here I have a 2 times 4 because I multiplied the 2 times the 4. I also have a 2 times the 5 because I multiplied it there. Basically this symbol will just go in between it, whether I'm adding or subtracting. So if I do the same, I'm going to have a 3 times 6. I'm going to have a 3 times 2. And since in this case I was subtracting, that's the symbol that goes in the middle. And if you do the math, you find out that that works out to 12. Okay, so let me get a clean screen here. We'll just look at a couple more distributive examples. Well, just one more where I kind of go through it with you, and then you're going to try to basically fill in the numbers on a couple. So, let's do 5 times 3 plus 7. Well, why don't you give it a shot? See if you can pause and figure out what the right side would look like. Go ahead. Okay, so we're going to have to multiply the 5 and the 7 through, right? So I'm going to have a 5 times 3, a 5 times 7, and addition, it was in this case, so I put a plus in the middle. And that's what distributive property is going to look like. Alright, I'm going to give you 2 examples where I'm kind of missing numbers here, and you get to try to figure out what's missing. So let's put a blank here. Times 4 plus 1 equals 7 times 4 plus 7 times blank. So pause and see if you can figure out what goes in those two. Okay, you'll notice in distributive, whatever this number is, that's always the first number of the second two. So since I have a 7 here and a 7 here, it's got to be a 7 out front, right? And we've done variable expressions where you know that these two things, the 7 and the 4 plus 1, are mushed together, which means multiplication. I guess in the other examples I probably had at times here. So that's the 7. Since the 7's out front, it's going to be those first two. And then you can see I have a 4, which went here, and a 1, which needs to go here, right? So a 7 and a 1 we're missing on that one. All right, let's do one more. 9 times 2 minus 1, let's just stick simple here, equals blank times blank minus blank, 9 times 1. Give it a shot. Okay, so in this case, the 9 is what I'm multiplying through to both, right? I already have the 9 here. My other 9 should lead off that set of parentheses there. And since I'm multiplying the 9 by the 2 first, that should be a 2 there, right? Alright, so even if all that stuff I talked about in the beginning with those rectangles and breaking them up and showing you one of the reasons we can do distributive, even if that's extremely confusing to you, if you get this basic part where you kind of think about how it, gets multiplied by each part of whatever's inside the parentheses being added or subtracted, you're actually pretty much on track. As far as its future usefulness, the place you're going to use distributive the most is probably pertaining to mental math, and we'll certainly get to that as it becomes necessary. All right, see you next time.